Okay, so IS-404 historically has a kind of a unique dynamic reputation to it. Usually as people go through the class at some point, particularly as we get into the next 4 or 5 weeks, people decide in their head, even the best students in our program, I'm not going to use this. Why am I doing this? I don't like this. And so here's Drake Loud from Paraveda, one of many, many, many people who have a story that's similar. Oh, all right, hold on. Let me. That's really quiet. Yeah, he could do better. All right, let's try that again. That's not any better.
What a voice.
All right, that's it.
What a beard.
No.
I think usually it's this little
Try pseudo.
At Paraveda Solutions.
Okay, that's getting
Now,
better.
technology consultant or even consulting can sometimes be maybe a loaded word or even.
All right, I'm gonna start it one more time, but let me just.
So what
Hold on,
we
I'm
do
gonna-
here is we go into organizations.
Okay, I'm gonna do it.
Hey,
Okay, just one more time and do it on.
everybody. My name is Drake Loud.
Yeah,
I am
no kidding.
at Paraveda Solutions. Now, technology consultant or even consulting can sometimes be maybe a loaded word or even an ambiguous word. So what we do here is we go into organizations. They typically have some sort of problem on why they're bringing us in. We pitch services or solutions on how we think best to solve that problem or even the overarching problem. And then ultimately, the solutions tend to be rooted in some sort of technology. So we're a technology firm largely, but we also do business strategy and a few other services. So I graduated in, 2018, so only a few months ago, through the MISM. And after accepting this job at Arpanet, I moved up here to Seattle and have been here since. So I wanted to quickly talk about IS-404, or really just kind of the fundamentals of IT. So that is like setting up your technical environment, meaning your web server, your Active Directory, DNS, whatever. Now I remember going through the program and not thinking that it was very interesting, or even that it was applicable, but I've since changed my mind. Now I actually changed my mind while I was in school. You can talk to Thomas Serby on that. I've repented in a way, because I used to really hate it. But the thing that's really great about those fundamentals, although you, one, aren't an IT major, so probably aren't planning on going that route anyway, but working in IT, or really as a technology professional, you will be exposed to problems that involve those technologies. So just last week, for example, I was in a meeting, a client meeting about, we were talking about infrastructure, particularly Active Directory and querying LDAP. Now, if I didn't pay attention in those classes, I really wouldn't be able to participate in those conversations. And that can come across poorly when you're trying to figure out, when you're trying to pitch a service, but even more so, how can you think of a full technology solution when you're not fully aware of all of the different technologies that are out there, or even how everything connects together and works. So it's been incredibly useful for me here, having a full breadth, at least a shallow breadth, I guess, of the different technologies, which I learned in that class, all about just the basics of IT, right? I think it's almost a prerequisite even. So don't be daunted by all of that. You can do it. The program's great and will help you be prepared for your first job, wherever that might be. But that's it. Enjoy the program. Hope things are going well.
He can't hear you, but I'll tell him you clapped for him. What's his name again? Drake Loud, and he was at the. Did many of you see him on? What was it, Friday? Thursday. Okay, that's right. It was Thursday. Yeah, so he was at the Bounce House event over Lowe's Extreme Air Sports. So good guy to get to know. Okay, as we get into this content, I want to make, in my mind, everything fits neatly into boxes. We're going to cover, the physical layer today. We're going to cover the second layer, the data link layer next time. Then we're going to cover the network layer. So everything in my mind is neat and blocked off. But I want to make sure that you guys are capturing everything and feel satisfied that you got what you feel like you need to get. So what I'm going to do going forward is, this is not required. This is optional. After any given day in lecture, I'm going to throw out a little link in Slack and say, hey, if this topic was too fast, too slow, if you feel like something was off and you didn't catch everything that you needed to catch, just let me know. So if you tell me something like, we went a little fast on this topic, I'd like to understand that a little bit better, then I will come back the next class and fix that. So I don't want to hear about it at midterm evaluations or at the end of the semester. Just tell me now. So that's the idea there. But you guys have a big load on you, so I don't want everybody to do this every time. But just like if something is off on a particular day, just let me know if I need to go faster or slower on something, or repeat something, review something, and I'll be happy to do that. So just warning, I'll put that out there. It's not required. It's only if you feel like something was off. Okay, last time we covered some Linux stuff. And so just for giggles here, let's just do a little pop quiz, not for a grade. But all right, let's just see if you can answer about 3 questions. So you can write it down on a computer or just store it in your head. So first question, if you were to list all the files in your current directory, what would be the command to do that? Okay. Oh, but don't say it out loud.
Oh, sorry.
Okay, just do,
Are you
okay.
expecting this?
Two more. Okay. All right, so I'll ask maybe 2 more questions, and then you can tell me what the answers are later. Okay, next question. If you were to list all of the contents of a directory, including the hidden files, what would be the command for that? Okay,
Sorry.
for the people who don't know. Okay, if there was a file in there called hello.txt, and you wanted to see the contents of it just parroted back out to the screen, what would be, in your head, the command that you would use to list out the contents of that file? Not sudo, but thank you. That makes this even more fun, giving me the wrong answers. And then lastly, if you wanted to view regardless of where, you're in some mystery location, mystery directory on the computer, and you want to see the contents of the PASSWD file, what would be the command to do that? Okay, so for the hidden files, how would you display those? ls-a would work. If you just wanted to view the contents of hello.txt, cat, okay. And then how about that PASSWD file? So you're anywhere. I like how sudo is the answer for everything. Well, we just want to see a list of the users, or just the contents of that file. So you could just do, so the key part that I'm thinking about is, it's cat again, you just want to view the contents of it, but then where is it at? /etc, etc/PASSWD. For the shadow one, I'm pretty sure we have to use the sudo command. Questions like that, maybe even just fill in the blank, might be on an upcoming exam. Speaking of stuff, yeah.
Could you repeat the last one?
Where would you find, like, how would you list the contents of the password file? I don't know if I'd actually do that question. The other question's more likely. But you just do cat space /etc/PASSWD. So speaking of the stuff that would be on the exam, so in Learning Suite, in the content area of Learning Suite, as we get through each day, I tend to append to this study guide. So here's some stuff that you should be knowing from day 1, some stuff from day 2. So I'll just make up something here. For day 2, it says identify, differentiate visually the components of a computer. So if I showed you that wouldn't be this easy, but if I showed you a monitor and I give you a multiple choice question or a fill in the blank, is this or is this the CPU, true or false?
Yes.
Yes. Pseudo. So we can do. So we can do something similar for the Raspberry Pi. You already had a quiz on that. I'm considering the stuff in the first few days lightly, even the Linux commands, although I do think for some of the commands that we covered in class that I will have you do some fill-in-the-blank type of stuff. So you'll know those pretty well by the time you get through with the homework assignment here and Wells stuff, etc. But it'll get probably a little bit tougher as we get into the next, I don't know how many weeks it is, but 4 or 5 weeks of just strictly networking content. So, but I'm planning on appending to this document all the time. And historically, what groups have done to do well in this class is because there's a lot of terminology in this class. And so, what's a piece of terminology? Like what's TCP? What's UDP? What's a router? How is it different from a switch? So there's just a ton of, what's a hub? What's a bridge? There's a ton of different terminology that we use in here that is hard to keep in your head and learn. And so historically what students have done to do well is they've gotten together in their groups and just done study sessions where they talk through those vocabulary words on a regular basis. So I put that out to you as a possibility for what you might do, and then you could use this as a basis for your discussions. All right, I think we're from there ready to go on to the slide deck. Any questions on anything? Yep. Okay. Okay, the key topic of today is the physical layer. But before we get to some of the physical layer concepts, I want to just tie up some of the previous things we've talked about. So you did a hardware lab. Do you have any questions related to the lab itself or just hardware? Just the basics of the computer, its main parts, its processor, its memory, inputs, outputs, yeah?
So I remember when I was doing the work orders, a lot of the parts I was trying to add to my work order for the custom computer, it would say like, oh, this isn't compatible with your power supply, your motherboard. And I didn't really understand how to make sure that all the parts were compatible with each other.
Okay. My hope, based on the previous times that I've used that website, is that it tells, it helps you avoid adding something that's not compatible. If it didn't, then the assignment was harder than I intended it to be. So do your best.
Maybe
And
it's just me having a hard time.
okay, yeah.
There was a button up on like the top left of the site. It was automatically checked for me. I don't know if it wasn't for you, but it was like an option to automatically remove anything that isn't compatible. So also, if you like add the components before adding things like the power supply and things like that, that just kind of help the other stuff, then it'll help you to get the right power supply and that too.
Good to know. Other questions, thoughts related to anything hardware related? Okay. In terms of how that fits in to our overall knowledge base, so we have hardware sitting at the bottom of this stack of information. Upon hardware, we put on operating systems like the Linux operating system or Windows, and then on top of our operating systems, we put applications that we learn how to write in our programming classes, and then users, of course, use those. Historically, this is how we built most things. Unfortunately, this could be a little bit inefficient because if this was a server supporting some great application that you wrote, typically a server is really only running, in terms of its hardware utilization, at less than 5%. So let's take for example our AIS website or our IS News website. So historically in a business, you might spend $5,000 on a big beefy machine, throw it in your data center or somewhere, and then it's getting 5% utilization. And so if you do that, several hundred times across all of your different websites, that's a problem. So noting that, kind of our next generation of technology ended up being virtual machines. And we have two kinds of virtual, so many, well, perhaps, have you guys installed VirtualBox and used that yet? Not yet? Okay, well, at any rate, VirtualBox is running, you probably will at some point. VirtualBox is running on all the computers in the lab, and oftentimes we use that to bring up a whole bunch of other Windows operating systems, plus Linux and stuff like that, and have them all communicate and talk to one another all on one box. And so if this were the real world, what we could then do is take our $5,000 box and have maybe 5 or 6 operating systems with applications running on it. So rather than having one application running at 5% utilization, maybe we have closer to 20 running at average 5% utilization, and then we're getting a good bang for our buck. And so the way that works is we buy our hardware, and then we put an operating system on there, for example, Windows or Linux, and then we put on a hypervisor, which is the software that can then host other operating systems. So we might have Windows here, we put on our hypervisor, and then we again install 2, 3, 5, 10 versions of and instances of Windows, etc. And then we install any supporting libraries and then our application itself to run a whole bunch of different things. If you know, you might think, hey, this seems a little bit inefficient. Now we have Windows with Windows running on top of it. Like, why are we doing that? So sometimes we strip that out and we just have hypervisor software that talks directly to the bare metal, and then we put the guest operating systems on there, and then we put our applications on top of each operating system. Any questions on hypervisors? Yeah.
So it seems like it's a lot about the utilization of the hardware.
Uh-huh.
So could I potentially just buy like another desktop and then somehow use a virtual machine to use that hardware on my laptop? Or am I misunderstanding what they mean by utilization?
It's more about you buy a beefy machine, and to support the IS News website, it really doesn't, it only takes a tiny fraction of it. So let's put on as many websites as we possibly can, rather than buying new servers, new $5,000 machines. So don't have 10 machines, have one machine, and have it running at 100%, rather than 10 machines costing $5,000 each, running at 5%.
Okay, and why do we have to have a hypervisor for running multiple websites rather than just putting the website files on the server?
Okay, why can't we just put multiple websites on there? Well, one reason might be compatibility. So in terms of your guest operating systems, you might have something that only runs on, let's just say, okay, let me just go through the stack and give you an example. Let's just say that we're running Windows 2019 server here. And then we're running some old ASP application that's not .NET, and maybe it only runs on Windows Server 2008. So we've got some ancient, there's a lot of legacy code out there that we have to support to run our organizations today. So maybe we have Windows 2008 on there, and it's running something. But then we also have Linux running on there, a certain version of Linux with a certain stack of libraries that supports a particular application that was written 10 years ago. And then we have something that was just written yesterday, and it needs to be supported. So in terms of all the libraries that get put on our operating system, the versions of the operating systems we're running, sometimes they're disparate, they're disparate, they're different. They're not the same thing. So that's one reason why we might do this. Okay, so assuming we have a whole bunch of different operating systems running on our hardware and we're utilizing our hardware well, there's still a lot of wasted overhead here. So as smart people got to thinking about this, they're like, okay, so I'll give you, here's another thing that might happen. Maybe we're running our production, like let's just say we're Facebook or something, and no, actually let's go small. We're running IS News. We've got a production version of IS News running, and then we have our development version. Maybe we have 2 or 3 development versions of IS News that are being worked on by developers. If we put each of those onto a different Linux instance, a different Linux operating system instance that's each using like maybe a third of the hardware, that's kind of a big waste. Operating systems are huge and heavy in terms of the draw on your RAM and your CPU and stuff like that. So smart people got to thinking about that, and they thought, hey, can we do even better than this? And the way that the next step was to go with containers. And so with containers, the idea is you have one operating system. So again, let's just pretend we're using Linux. And as we look at 3 different versions of IS News, there's just a little bit of difference in the code base. What we could do with a container, it's a different way of doing things such that we have our applications running, and the only additional resources that are taken up are the ones that are used to support just the application, but it doesn't create a whole new instance of Linux being installed. There's only one version of Linux being installed, and so we leverage our computer hardware a lot more effectively. So that's kind of where things have gone. That's just kind of background information that I think is nice for you to know. Do you have any questions about that? In terms of how the cloud works, it's pretty cool. You're like, oops. In terms of how the cloud works, you say, spin me up a new Linux machine. How does that work? Well, all it's doing is doing this. You've got one piece of hardware, zoom, spin up another version of Linux with a whole bunch of stuff pre-installed. Okay, question? Yeah.
This might be a little theoretical, but where can you go from here? If each time the purpose is to reduce it, and obviously, if you knew, I assume you'd be making $1 million.
I don't know what the next step is.
That's
I'm just
right.
hoping to get through today. But whoever comes up with this, hopefully they'll make a lot of money. To your point, yes, technically and historically, I would run a whole bunch of websites on a single server, as long as everything that I was writing was compatible. So if everything ran under the same version of Linux, the same version of PHP or Python, the same version of MySQL, as long as everything fit in that box, I could put multiple things onto one computer. But this also comes into play. That doesn't always work out, especially as you start supporting 20 years worth of applications. Oftentimes we don't throw things away. So for the internet startup of today, you're like, hey, I'm going to use the latest and greatest of stuff. But once you've been around for 20 years, you're now supporting 20 years worth of different platforms. So older businesses get interesting. Okay, again, not on to the physical layer yet, but now going on and talking about the Raspberry Pi. I wanted you to note that it has something on here called the GPIO header. So the general purpose input-output header. And each of these pins allows us to either get direct power of either the 5 volt or the 3.3 volt variety, or it gives us a ground, meaning power goes in a circle. It goes, in one end and then out the other end. You have to complete the circuit in order for your devices to have power that you're connecting to. Or we have a lot of these ones that have numbers like GPIO 17, 27, 22, etc. Those ones are meant for turning on and off power programmatically. So whereas if I go up to the upper left-hand corner there, the orange and the 2 red dots are steady power. They're on all the time. The black ones are your grounds, so that's where you complete a circuit if you started the power from one source. And then all the numbers are ones that you can turn on and off programmatically. So just at a high level, I want you to understand how that works, and then I was actually going to demonstrate that. So let's take advantage of using steady power. Yeah, okay, where's the question? Yeah.
You might not want to get into this, but 27 and 28 were way different for some
White.
reason, and I didn't understand what they were.
Oh.
But it also said advanced use only, so.
I'm still a little bit new on my Raspberry Pi journey, so oftentimes what happens is I find some cool tutorial that I want to do, and they give us a pinout chart. They say connect this to here, and this to here, and this to here, and I just do what it says. So, yeah. Sometimes I spend a lot of time looking it up, but there ends up being IT ends up being a very deep black hole where you just spend a lot of time and you know more, but you don't ever reach the end. I've found it's just how it is.
Professor Kettles,
Yes.
what is the numbering system?
What's the
2,
numbering
3,
system?
4, 17, 27, 22, 10, 9. I'm trying to find.
Oh, that's a little funky, isn't it?
Yeah.
Um,
Because it is that. Oh,
all right.
15, 17, 19.
Just
Well, that's
another-
better.
Maybe they made a mistake in there. I don't know.
Exactly.
So
Okay, that makes more sense.
here's one of the weird things. Okay, so along, if I tilt my head this way, along the left-hand side, that's just all numbers, all odd numbers in order, and along the right-hand side, it's all even numbers.
That makes sense.
I find it a little bit disconcerting that, like, next to 15, it says GPIO 22.
Oh, what the heck?
I know.
Ah.
So
I don't like this.
I'd like it a little bit better if they just called that GPIO 15, but whatever. Anyway.
No, I was having.
At a high level, just know that this is a pinout chart, and your tutorials will say plug in here, plug in there, and when you start dealing with this, interacting with it programmatically, you're just turning on and off GPIO 10 or GPIO 22, and you can find where that is.
What is the GPIO again? I'm sorry.
So it just means general purpose input output. So these little pins here and these little pins here are so you can connect to external devices. Remind me to say something about nuclear missiles in just a minute. Okay. Okay.
We've got a plug here.
Okay. Yeah. This is great. Thank you. I just wanted this to be visible. Okay. So I have just plugged in. My Pi, and in pin number 1, this is 3.3 volt. Technically, the power coming into your Pi through this plug is 5 volt. The power that flows through your Pi after being stepped down is 3.3 volt. So by default, every device that you connect to it through these pins is also going to receive 3.3 volts of power. So right here in pin number 2, I have a connector here. It's ready to send out 3.3 volts of power, steady. It's not turned on or off. Sorry, pin number 1. It's steady. It's always just giving out 3.3 volts. It's not programmatically affected. And then over here in pin number 6, I have a ground plugged in. So that's where I'm going to complete things. And I have a little diode here, a light emitting diode. So if I plug this in, okay, I get a little light. Now, all the tutorials will tell you that if you leave this thing, a diode plugged into 3.3 volts, it will burn out. So I'm doing it in short periods of time, and I haven't burned it out yet. Okay. Pardon?
Nothing. I was just.
Okay.
I thought you were about to
So-
actually plug, and I'm just like, oh, burn it.
So electricity, you would think of it like you think of it like pressure going through a hose, and if you push too much amps through a hose, your hose will burst. This one is kind of like a relatively tiny, weak-walled hose, and it will blow if we push too much power through it for too long.
Could we like blow it up?
Yeah, it'll just. I don't know if I'll get any smoke, but it'll. Yeah. So typically, so in all of your examples, or in a lot of your examples, it depends on the equipment that you're attaching to it, the thing that you're turning on and off. They're going to put a resistor in line. So a resistor is to impede and lower the amount of power that's flowing through to your whatever your component is. So it so happens that with a buzzer, things that go ee, that I can put on here, those ones can handle high power well, but the LEDs cannot. And many other components are going to require that you put a resistor in line. The question is, which resistor do you use? So here are resistors, and probably about 1,000 of them, I think, is what I purchased. And they have different colors on them. So how do you know what are the right ones to use and not the right ones to use? Well, first off, your little instruction guide for whatever you're doing is going to tell you. Yeah.
I just had a question about the last slide. I'm kind of new to this. So
Okay.
in the diagram, everything was connected, but this one that we're dealing with, it's not. So what are you, like, could you talk about what you're actually connecting?
What am I connecting?
In the diagram? You're just doing
I've done the exact same thing that's in there, except I don't have the resistor on there yet. So there's a wire physically connected to 3.3 volt going into the long end of the LED, and then there is a wire connected to the ground, and that's on there. I could, if I just took this out, I could lower it a little bit lower and do it, but just for working with it, I'm using these jumper cables. So yeah, I'm literally doing the exact same thing as in there. So I'm creating power, positive power going out from 3.3 volts, coming in the long end of the LED, and from the short end, that's the power return, it goes into the ground.
Okay.
And so the only thing this will blow it out because there's too much power going through. So I'm supposed to insert a resistor in line according to that picture.
Okay.
So, and that's coming from the power out. So the power that's going into the LED, I'm going to reduce the flow of that electricity. So, yes.
Are there any of the, what are they called, the little pokey thingies? What are those called? Those things, are there any of them that emit less than 3.3 volts? Like, could you put it on a different thing
okay.
and have it run without a resistor?
All right, so back it up a little bit. The Raspberry Pi is one of our more famous and most common computers that we can mess with. And something like this, or more particularly like this, is a pin-out chart saying what every single pin does. We can buy a lot of different computing devices, ones that are called Arduinos. There are lots of different computing devices out there, and all of them come with a pin-out chart. And as you look at different ones, you realize, hey, I noticed that pretty much all of them have the same stuff on them. They all have a ground. They all have, constant power. And then they all have pins that you turn on and off. It's just they have more or less of them, and sometimes they have specialized pins. So I don't think I answered your question. Could you go ahead and answer it again? But that's the high-level idea.
It's not the lowest is the three, whatever that.
Yeah, my question was just if there was like a pin that just gave off less than 3.3 volts.
So yeah, to your point, I don't know for sure. I think all of the GPIOs put off 3.3 volts, but we'd have to do some digging. I think our options are constant 5 volt, constant 3.3 volt, or on-off programmatically controlled 3.3 volt. That's as far as my knowledge goes so far. You can build a lot of cool stuff with that knowledge. Okay, so let's talk about the resistors for a second. Many of your kits came with something that might look like this, and if you were like me, you just threw it in a drawer for a couple of years. You're like, I don't know what that is. I don't do electronics. But now we do. All right, so let's talk about what it means. So our bags of these little resistors, they have colored bands on them. Sometimes the resistors will have 4 bands, 4 colored bands. Sometimes they will have 5. Sometimes they will have 6. For me, again, I try to think of things simply. The only thing that really matters to me is this multiplier, which means the higher this number goes, the higher the resistance in there. It means there's less electricity going through. So if I have a gold or a silver band in one of my in my second to last position, whatever that is, gold or silver is going to give me almost no resistance. Black is almost no resistance as well. But as we go, get between red and purple, that's a ton of resistance. We're really restricting the amount of electricity that goes through. We restrict the amount of electricity that goes through so we don't blow up our component. Our components are all rated for a certain tolerance. If you run too much electricity through, it's going to blow. So pretty much all of your project. Now we're not electrical engineers, but we are smart enough to just follow the instructions if we know what the instructions are doing for us. Instructions just tell us, hey, use this one or that one, and now we know what we're doing. We're stepping down the electricity. So let me go through 2 of these. I don't have my projector up yet, I apologize. But, oh my, I can't even see this. Please stop in the dark. This one in the second to the last position is black. So regardless of what the initial numbers were, black is a relatively low amount of resistance. So, and let me see what the other one is. This one, in its second to last position, is gold. So, gold is ridiculously low resistance. All right, so let's try this out. I'm going to put in ridiculously low resistance. And what do you think is going to happen compared to just running straight power? What? All right, here we go. No, so it's it's pretty bright. It's pretty bright. Okay, this one with the black multiplier has more resistance in it. So what do you think is going to happen? What? Dimmer. Follow, thank you. All right, so let's put that in there. Put it together. Okay, can you see it? All right, so it's there, but it's dim. Okay. So I don't have a memory card or anything. I don't have a card in here at all. I just have the Pi in here without its SD card. Again, that pin 1 is just 3.3 volts of constant electricity. Okay, so that's enough. Any questions about that? Yeah.
Is there any part of this wiring that we shouldn't touch?
So sometimes we hear the word short circuit, and the idea of a short. So when I create a connection from here to here, this is a circuit. The power's coming in one end, it's coming back out the other end. When you connect pins that or parts of electronics that aren't supposed to be touched, it creates a connection, a shortcut path, and we call that a short circuit. So yeah, sometimes things will break if you short circuit, either permanently or temporarily. Sometimes it'll reset the device, any electronic component. Are you asking, are you going to injure yourself if you touch this while it's on?
Get electrocuted there.
Are you going to get electrocuted? Well, I don't know. Try it. Let me know. I believe that the 3.3 volts running through here is not super dangerous. I think you could. I haven't tested it yet, but I'm pretty sure that's low enough. It's not going to mess with you. But definitely, in contrast, in the server room. In the server room, we have a lot of electricity in there. You go put your fingers in the sockets up there, you're going to kill yourself. But this kind of stuff, I think we're low enough where it's okay. In fact, when I watch the guys doing videos of this, like they just like connect it with their fingers. Wow. Like they're like, oh, you know. So yeah. So I guess there's 3.3 volts touching me right now, and I'm like, I'm not dying.
I think 5.
So I should try the 5, maybe.
Need backup.
Anyway. So I just wanted to give you a little bit of understanding about this stuff. Okay, here's the next one. Here's the next slide. So the difference between the previous slide and this slide is what? It's connected to basically an on and off pin. We can control that as follows in Python code, which you are now becoming proficient in. So this over here is the Fani Id Editor, which you will find in the start menu of your Raspberry Pis. You just open that up under programming. You type in some code like that. You type in some code like this in that coding box, and this is all you need to turn things on and off. So this one, it just says, you're telling it, yeah, I'm going to be using an LED. I'm going to need the sleep library. And then here's the key part, the line 3 right there. I'm going to create a variable called LED, which corresponds with pin GPIO 25. So if you're connecting to other pins on there, it might be GPIO pin 17, 15, whatever. So you connect to 25. You're told in your instructions probably to connect. Physically you're shown where 25 is. So now you have a connection programmatically to 25, and then this little loop right here turns it on. Pauses for a second, turns it off. On, off, on, off. So we've just gone from constant power through one pin to now we can programmatically turn it on or off. Yes, Bonnie?
Okay, so I noticed that you're referring to the Pi guide. That's different from our data communications book.
Yes. Yes.
Where is the Pi guide?
The Pi guide is listed as a PDF document for the reading for your quiz. So yeah, it's the whole beginner's book that's posted there. Really, I'm only making you accountable in this class for the first 8 pages or 8 pages at the beginning where you get to learn what the hardware is in there.
Yeah.
But I want to make you aware that in the rest of the book, there are 10-line tutorials where you can turn light bulbs on and off and stuff like that. Yeah.
Can that work the same with your fan, where you can power it on or off depending on if it's...
Can you turn your fan on, your fan on and off? Is the fan running through the 5 volt or the 3 volt?
The 3.
It's running through the 3?
Well, if you're connected at 5, then you can turn it off.
Yeah. It wouldn't surprise me if you could just put the power input side through any of the pins and turn it on and off. Okay, so back to nuclear missiles. No, it's just-
I like where this is going.
It's not going to go very far, but but I think we look at something like this and we're like, oh, so what? I turned a light on and off. If you can turn a light on and off, you can turn any type of powered device on and off. You can launch missiles if you were connected to a missile device. You can lock doors. You can unlock doors. Just pretty much everything physical in the real world that's connected to electricity, you can alter its state using some Python, maybe some Python code and connecting it to some pin where you turn it on and off. Anyway, just as a base level of understanding, this is true. So with this, hopefully you feel comfortable doing a whole bunch of your projects later on in the middle of our semester for your group projects. Hopefully you feel more confident. Since I did electrocute myself, you feel like, hey, I could turn to page 128 or whatever in the book and I could do this too. Yeah?
What program did you say?
It's the Fani IDE, Fani Python IDE under programming. Some
It should be installed already on.
yeah, it's possible depending on also how much stuff you install with your Pi. There's light versions of that you can install when you do your Raspberry Pi installation. There's also heavier versions. Sometimes it doesn't install all of the different programming environments, the IDEs like this, and so sometimes you have to do a little command prompt upgrade and get the additional stuff in there. Up there you can see other things you can do in Fani, like hello world, and then here's an output down here at the bottom. Oftentimes if you're interacting with some device that has an input on it, like a temperature sensor or a distance sensor or whatever, you might during development just have all of your stuff, all of your output coming out here through the bottom so you see what the numbers look like. And then later on you could capture those numbers in some while loop, like if this is between this range or that range, do something special. Okay, so that gets us out of whatever that was, day 3. Day 4, do you have any questions about Linux? Too many questions about Linux. Okay, I forbid you from asking me questions about Linux. On the off chance this goes wrong. No, but do you have any easy questions that you want to ask me? Yeah.
So the only commands we need to know, are they the ones listed in the file that you gave us, the document?
Yes.
There's a lot of there.
Oh, there's so many.
Yeah. So what you could do, and I don't want to depress you. That's not my intention. You can go out to the web and you can say, Linux commands, and it'll come out with several hundred commands from that like bin folder, or sbin. And I don't want you to be overwhelmed. I just wanted to introduce you to the most common tasks that you work on and the most common commands. From here, you spend the rest of your life, if you work on Linux, just learning them. It's just, just like you might pick up a different language, you just practice with it every day. But you already know a lot, so feel good. You know a lot. You know enough to teach yourself at this point. Any other high-level questions? I do just want you to know, like the first half of the list of commands that I went over in class on the sheet that I posted. Yeah.
So it seems like basically everyone uses like Mac or Windows, and so I guess Linux is used for like other kind of stuff. Like, what is it used for, and like why, if no one uses it, like personally, why do we use it for other things?
Okay. So.
Like, why wouldn't we just use Windows or Mac for all the stuff we use Linux for? Like, is it better at stuff?
Okay, there's a couple answers. Arguably, and I have to pause, make sure I'm not going to say something that's a lie. Arguably, Linux is by far the most popular operating system in the world because it runs on all your Android phones. So, by learning the basics of Linux, you know how to work on servers as well as Android phones. Now, also, as it relates to servers, there's some debate about this, probably fear, uncertainty, and doubt that is put forth by Microsoft about which is the most common server. But pretty much everybody who programs uses Linux. Everything out. So if you're a programmer, you're going to be putting your stuff typically on a Linux machine. If you're, working in project management or something like that as your career, you don't care. But if you work in technology, either on the IT side of the house or in development, all your stuff's going onto Linux and supporting websites and mobile applications on the back end. That's where it's all at. You can write stuff on Windows, but even Windows now is saying, hey, rather than having you do .NET on our Windows machines, now we're going to let you just do now we're going to allow you to do Core and put that on any Linux machine. Like they're just, I don't know if that's thrown in the towel or what, but it's just been a done deal for a while. Yeah.
So just looking about the options you have, so the Mac So it's really easy if you don't know what you're doing in Linux to like damage your operating system and like shut your computer down. So is that really user friendly? New, but if you're like a coder and you like want your operating system to only do what you want it to do, then you're like, this is the best thing ever. But if you're just like some grandma, then Linux is just like the worst thing in the world.
It's okay. So another reason why we use Linux so much is because it's typically free. So as we've gone through many years of using operating systems like Windows, people don't like paying the $100 for the Windows license unless you don't notice because it's bundled with your computer.
Or you're filthy rich.
Your Mac is BSD. It's technically Unix. So whether we say Unix or Linux, it's a derivative. We're using Unix on all of our Mac machines. What's weird though is, as hard as we've tried, we haven't been able to get Linux to take off on the desktop. So it's been possible for a long time, but for whatever reason, it just found its home on the servers, and Windows seems to typically find its home on our laptops and our local desktops. But it's available and it's usable in that way. Let's talk a little bit more about Linux. So AT&T Bell Labs, and I understand Dr. Albrecht's going to talk about this. This will be a shorter version probably of what he's going to talk about. The AT&T monopoly, they got hit with an antitrust case, and so they weren't allowed to do certain things because they were considered as having a monopoly. One of the things they invented was Unix, not Linux, but Unix, the precursor to Linux. So it was a computer operating system that runs on our hardware. Well, because they got hit with this antitrust suit for being a monopoly, they were not allowed to sell computer operating systems. That was considered outside of their area of responsibility. So as part of the law and their punishment, they weren't allowed to sell this operating system called Unix that they'd created. So in the 70s, what happened then is universities got wind of the fact that, hey, let's pretend I'm a computer science professional. I'm over in the computer science department. I find out, word on the street, just like when they're, after a basketball game, maybe they're giving away free hamburgers here in town. If we get over 100 points, you've heard of those type of promotions, right? Well, the word got out about the promotion that if you ask AT&T for a Unix operating system, you didn't have to pay for it. They were required by law to give it to you for free. So what did everybody do?
They asked AT&T for a Linux operating.
Everybody's like, woohoo! I'm going to get myself a free operating system. So nerds were super excited about this. I hope I don't hurt anybody's feelings. I love nerds. I'm kind of nerdy. So when I make fun of them, I'm also making fun of myself. Okay, so unfortunately, the party was not going to last forever. I was gonna take off this guy's name. I've kind of messed up my little game here. So this is Richard Stallman. Richard Stallman, he put together this Free Software Foundation. I think it's a source of new, if you've heard that as well, this licensing related to free software that you get that you can run on Unix systems. So he helped put together, so your operating system, it has a kernel. It allows it's code that allows your software code that you write as an application developer to talk to, it's the interface layer to talk to your hardware and your CPU and stuff like that. So your kernel is just kind of some low-level stuff that talks to your hardware. But a lot of utilities that sit on top of that, I guess if we were to talk about our Windows world, like Solitaire, Minesweeper, Paint, like all these little utility things that are also bundled with your software, Richard Stallman helped a lot of that stuff be written and put out in an open source license format. So everybody could see the code, you could share it, it was free. So now the party's awesome. You got somebody who gives us the base operating system kernel for free. You got somebody else who is helping organize all this free utility software that sits on top of the operating system. So everybody that uses computers or that doesn't want to use Windows in particular are super happy about this. And so a lot of programs that are out there being written for many years are being written for Unix machines and languages primarily C. Okay, but one day the party ended and we still had all of this free software that was utility software, but we didn't have the core operating system itself. The core of the operating system for Unix. And so what happened?
Someone created one.
Yeah. he was like, man, I sure wish I could get a free operating system. And so he wrote it. And so he wrote the kernel. Now the irony is, as I understand it, this guy did much more work for Linux than he did. But he gets all the glory. I'm not mad, but I'm just saying it's kind of a bummer for him. Anyway, you'll have to do your own history research. That's how I understand it. So he wrote the kernel, and now he becomes the great hero. He becomes the kernel so that you don't have to pay for their licensing. Off we go. Okay, moving on. Any other questions? Just fun background stuff. Yeah.
Is it kernel a software piece or hardware?
Kernel is just is considered the operating system, but it's just the lowest level of the operating system. Okay. It's software. All right, so asking you a question. Now I'm kind of shifting gears a little bit. I don't know if we're ever going to get around to the physical stuff today, but we're almost there, I promise. What are some things that you think a CIO needs to know? So we're going to put on a completely different hat right now. What are some things
Everything about everything.
a CIO needs to be everything about everything? So are you being trained to become a CIO as part of this program?
Eventually.
Yes. I'll leave you to think about that as you go through. Well, what are some things specifically you think they need to know? You're like, I don't know, I have no idea. Yeah.
If there's any sensitive data that they need to keep quiet.
Okay. Security, data storage, data sensitivity. We could even put this under, if we talk about data specifically, not even just security, but just data specifically, we might call this data governance. This idea that we're like some quasi-country organization and we have to govern our data specifically among other things. Yes. Yeah.
Say strategic objectives of the
CIO needs to know about the strategic orientation of the organization. Sometimes different key strategies we have are we a low-cost provider or are we a premier provider of whatever we offer, whether it's cars, whether it's food, airline travel, etc. What else does a CIO need to know?
I was just saying, along with that, they need to know how their technology fits in with their business model and strategies, and then also
Yes.
be thinking of ways to improve that using technology.
100% agree. So I won't repeat it, but that's 100% correct. What else does a CIO need to know? Well, those are a couple good answers. I won't answer them all today. I actually used to teach a class that was about CIO stuff. Not currently. One of the things that I think the trap that many of us fall into as part of this program is that we really get to see, we start to see the world, or at least speaking of myself in particular as I went out there and created my career, as I tended to see the world as software only. We create software that meets business objectives and everything else is just meaningless. That's like plumbing, that's just electricity. You know, it's like, it has to work, but what I'm doing as the software developer, that's what's really important. I don't really care about anything else. And I had kind of that attitude for a long time. And that's not a good attitude to have. So there really is another side of the house. Drake Loud talked about how it was important for him to go into meetings and be able to talk about what was going on, be intelligent and conversational about what the IT people were doing, because nothing runs without the IT stuff being in place. And as it relates to CIOs and technology, I want you to think about the fact that on the one hand, yes, they might oversee the application development that meets with our strategic objectives, but on the other side of the house, all of the IT is something that they also have to understand that supports that. So from an IT person's perspective related to infrastructure, this is how they would see the world. Pretty much everything in this lower box area and along the side is IT stuff that they care about. So they have their infrastructure. Let's just say you're an organization with 80,000 employees. You've got end user devices. Everybody's got at least 2 or 3 operating systems, every single one in the cloud, on premise. All the computing power. You got to know, should I be running an i5, an i3, an i7, some other advanced things? Do I need GPUs? Am I doing some type of Bitcoin mining? Like, you know, do I need GPUs for that? What's all of my storage requirements? What's all of my networking requirements? My on-site and off-site data centers. Security. As we move up this stack, we have application platforms. Don't worry about that too much. That's maybe like .NET that you would install on your Windows server so that it can run your website. going up one more level, this is maybe more where you guys are sitting right now. This is your applications. We're going to build some website on our local machine. We're going to put it. It's going to sit on the rest of this stuff. And then at the very top there, this is the functional area of the organization. So depending on your business, you're processing loans, you're selling cars, you sell hamburgers, you have processes that allow you to do that. Everything else supports that. So you have applications that support those processes that you diagrammed in 401. And then you have all this IT that supports it. So I want to emphasize that if you want to be a top leader, you have to have an appreciation of all this other stuff and be okay with it, and not be like, ew, that's so gross, IT. You have to be like, I respect that. Like, maybe I don't do that, but I can talk to you about your switch, your router, your Active Directory, okay? Or you might do it as your career, it's fine. You guys are capable of doing this and making that career shift. But know that it's important and it's there. If you are a little bit bigoted about it and say, I don't care about it, then it kind of, can you see how that might limit your potential as a leader? So, yeah, because that's half the house. And oftentimes, you as a developer end up being managed by somebody who came up through this route. And they have a completely different mindset and culture oftentimes than you do. So, oftentimes people that go through the military are good in these other areas because it's about like readiness. Like in the military, you have to have all your planes, all your jeeps, everything's always fueled up and ready to go. So people oftentimes, maybe with a defensive mindset, come up through the IT side of the house, and oftentimes they don't like the offensive side of the house. Like, yeah, we're gonna, hit this deadline for this application, which is gonna change the market. They're more about stability. And they're like, hey, don't mess things up. Like, I have to make sure that nothing's ever down or ever broken. And it's a whole discipline and mindset and culture to be able to pull that off without the network ever coming down and stuff like that. Okay, this will be interesting. So look at the 12 minutes we have left. I guess I'll push this on to another day. All right, so starting to talk about the physical nature of things. So the OSI model is the overall framework we have for talking about data communications. As a conceptual piece, that's something that people thought of after they'd actually got everything working. They said, hey, this would be a great model to describe how two different communication devices talk to one another. Different layers of responsibility. Some people humorously call it the 7-layer bean dip of networking. And that makes it funner.
I like myself some bean dip.
Yes. As it relates to this model, we care about the areas of responsibility for getting from point A to B, primarily in layers 1 to 4 at the bottom. What happens is we start at the top with above the top with our application itself. Maybe it's a web server or web browser. The first 3 layers here are related to your application preparing its data to send across the wire. Once we get about here, we're talking about sequencing packets so they can be ordered and have guaranteed delivery. This is about addressing your packets for IP packets. This will be later. We're going to start from the bottom and move up. But in terms of Scotty's transporter beam, as we transport data from one place to another, we start off with some application data. We add in some sequencing, some addressing. We send it around across the public internet from point A to point B, maybe from office building 1 to office building 2 on different parts of the planet. Once we get to a particular building, we have a different form of networking that we typically call Ethernet that operates at this level. And then underlying all of that is our physical layer, which is just using physics, whether it be sound waves or electricity, to transmit ones and zeros. We're talking about that today. Okay, OSI model. Good thing is it looks nice, neat, and clean. The bad news is it was created as an idealistic way of representing the world after the world had already been created.
So it's pointless.
Well, not really. We still talk about it. And frustratingly, perhaps, we talk about it from 2 different frameworks. So this is the idealized framework that came second. This is the implemented framework that came first. So the Department of Defense, through DARPA, the Defense Advanced Research Projects Agency, they created the Arpanet, which was the precursor to the internet, a way to send data in packets back and forth. That got replaced. ARPA itself, that technology, Arpanet, got replaced with TCP/IP. It was a little bit better. And TCP/IP is categorized like this. So it's got some parallels. And unfortunately, on any given day, you might be talking with somebody and they're either talking from this reference framework or that reference framework. But the responsibilities are relatively the same in parallel as we look at the levels. The frameworks are nice because there's a whole alphabet soup of technologies out there related to technology or data communication. Here's some of them: HTTP, SMTP, FTP, SSH, SIP, TCP, UDP, IP, Ethernet, frame relay, CDMA. This is just kind of the tip of the iceberg. There's a lot of different technologies out there. I think it's helpful for us to have some type of organizing way to think about it. And so by identifying what level the technology sits in, the keyword sits in, that helps us kind of make sense of what it does. So as a practitioner, after you do stuff for a while, I totally forget about the OSI model and stuff. I'm more concerned about just the names of the technologies and I know what they do. So sometimes over time you kind of forget about the model itself. But this is a good starting point. We're going to talk about the technologies and put them in the place of, well, what do they do? Here's a repeat of this. It's the same info. Here's some key technologies that we hear about that exist at a given level of either the TCP/IP model or the OSI model. Okay, as it relates, I don't know if we'll have any more time to talk about this, but let's do building cables for a second. This is an assignment that's due for you. So my intention was to talk a whole bunch more about physical layer communication, and then we build our cable. We will build our cable first, so you can start on your assignment, and then we'll talk about more about the properties of physical communication later. Okay. Okay, we have a little camera here. Okay. On the physical layer, we're typically either communicating through a cable, a copper cable like this, a fiber optic cable, which I brought examples, or we might be using some type of wireless communication like we have in our ceilings. So this is commonly called an Ethernet cable, and we can test if our Ethernet cable is good using a device. I have several different types of these. I can test if my cable is good using a device like this. So I turn it on, and there are 8 wires in here. And as I click this, it's showing that each of the wires are connected. So it's a good cable.
Didn't one of them go red?
Well, that was the last one. That just said,
No, there's that one. The fifth one.
yeah, well, we'll pretend like it's fine. So, inside of your cables, there are 8 wires that look like that. So, how do we build cables? Well, when we build cables, we have a roll of cabling like this. There are a lot of boxes. If you want a different color, like yellow or green, we have different colors of this in the lab along the back shelving there. So you go out there and you clip off a piece. Each of you should clip off at least, I don't know, a foot or 2 for yourself to use at home. So you clip it off, and actually, let's just take that cable I had a minute ago. I have to go through this relatively quickly. Okay, so I am going to cut this off. Oh! So, it's okay.
I just cringe.
I know, it is really, really uncomfortable. Okay, so you clipped it off. So, all right, and then we got to take off the casing. So we want to take off about 2 inches of casing. So I just put this in a little bit. There's a little razor blade in here. I'm just going to push into it a little bit. And then I'm going to slide this off. Okay, there we are. All right, so there's all my, whoops. What's happened there? Okay. I've got a little string in there. This string is not going to be helpful to me. So the string is used to help pull the cables through the casing during the manufacturing process. I don't want that, so I'm going to pull it off. Maybe, where'd that little head go that I had?
To the top right, it's up there, far corner. No, sorry, on the.
I was going to throw it away, but I just realized I could use that right now. Wait, you see it somewhere? I'm not seeing it. I thought it was
Send it down on the top
It
corner.
fell.
It fell?
Somewhere.
Oh well. Darn it. Okay. Hopefully this doesn't take too long. Okay. So this is what we're going for. There's a particular order. T568B or something like that is the number, which is the ordering we put the wires in. The wires are just copper. So in a sense, it doesn't. There's nothing magical about the colors of the wires, other than we want them to match up on each side. That makes sense? So there's a standard for what order you put them in. And so we're going to do the standard 2568B or something like that. Okay, so as I look at this, the first one is going to technically be white-orange. So I need white. I need to separate all these. So, okay, I apologize if we go over for a minute or two. I'm going to do this as fast as I can. There's also countless, if you need to go, there are countless videos on internet about how to do this as well. Okay, so I'm going to untwist all of these. They're twisted up. Does anybody know why wires are twisted up? Yes. Good job. A quiz question. So, electrons have a habit of jumping wires, and for whatever reason, if you twist, there's less a likelihood of them jumping. Okay, so doing this relatively quickly, I'm going to go white, orange, orange. So so I need to get these things all flat, like they look like inside the head. So I got white, orange, orange. All right, my next color is going to be white, blue, white, green, white, green. All right. My next question is going to be white, or my next one's going to be white, green, so it matches up. So this is kind of an annoying process. They're stiff, and you typically kind of move them around a little bit while you're making it. So after white, green, the next one is blue, then blue, and then light blue. So I go blue, light blue. Okay, so now it looks like I've got 4 in here. Okay, so for my last few of them, I've got green, white, brown, and then brown. So I go green, white, brown, and then brown. All right. So one of the things is I'm trying to keep them in order, and I move them around a little to try and keep them straight. Okay. Now I need to cut this off, and I want to leave. So when I did the casing, I had a lot of extra space there, but when I cut this, I want to leave about ½ an inch. So I'm going to go over to the trash can and cut this off, and I want this to be even. Okay. I'm almost done. I cut the heads off. Hopefully, they're still in order. I grab one of these little heads, and with the clippy side down, I slide it in. And if everything stayed in the same order, then what should happen is I should be able to see at the top. I should see the colors kind of at the top of the pin. If they don't go in far enough, it's probably not going to be okay. Okay. It's in. It's not done yet. Here's the crimper. So we push this in here, and then I squeeze this about 3 or 4 times. Squeeze, squeeze, squeeze. Okay. And now I'm done. Let's see if it works. Okay. 1, 2. Oh! could you tell what happened? Yeah, I was doing it too quick. One of the wires slipped out of my hand, and so it reversed direction. So what do you do if that happens? Flip the head off and start again.
That's what I thought about this.
Yeah, I'm gonna leave this part in the lab so that you guys can do this anytime you want. Hopefully the lab is pretty good. Hopefully the lab instructions are pretty clear. Pull out a foot or two, your clip.
And that already has the wires in it.
Yeah.
Oh, okay.
All the tools are technically right here. Black bins. Yeah, so we'll have the big back connectors and here's the alright, I'll see you guys. Yeah, the boxes and things back in the class. It's all in the instruction. Okay. That's our first.
I haven't taken the
giving you a cold.
Looking over the questions, but I can't see retake it or anything.
Yeah. How about this? You must be about wire. Yes, the idea is that everybody can have one of these.
Cat 5 cable right now.
Yeah, well, my hope is let's have something good.
How you can find it.
Oh, yeah.
So you can borrow it.
I love it.
But we won't need you guys. I hope you guys build one. And then we'll all
Trips for
Yeah, you're good to know. Thank you.
No. Where are you gonna be? Are you gonna be at your apartment tonight?
Wow.
That was really funny.
What was funny?
Yeah. Honestly, great.
It's because I was trying. So in construction, you say like measure twice, cut once. And so if I was doing this like not in a hurry, I'd be like double checking. I got all the wires in the right order before I put the thing on. But I was in a hurry because we were.
Okay, yeah. Okay, so
Yeah,
I
should
should talk to you about.
should we
my
go over
run
to-
for, like,
I'll
a
follow
couple
you.
days,
Yeah, just find a spot on
and I've already
there.
looked over
Sounds
the
good.
schedule, and it doesn't seem like there'll be too much going on
Thanks,
with
that's
the
good.
class. We're doing
Make
the
it go.
cloud and like the presentation. But I just need to get your signature to test that I have talked to you.
Okay.
If you would mind.
You'll be, yeah.
Because it's like a university.
All right. You'll be traveling, and we'll do our best.
Okay, thank you so much.
You bet.
Dr. Chaos, I have a question. So the fund right now is connected to a 2.2. Is there any issue with that?
If I Google it, I thought like I just plugged mine in over the weekend. I think it's a 5 volt.
I did it in 3.3. I mean, you can go either.
Yeah, I don't think it's gonna matter.
Okay. Because if you put it in 5,
5 is better. It's more.
it's more, right?
Yeah.
It's more energy.
Mhm.
Are we gonna use LED or should I just take it out and take it?
Oh, do you need to do? No.
No, I have the tools.
No, you don't necessarily. Only if you guys are doing projects is that
Okay.
gonna matter.
Okay, cool.
Yeah. So if you just want to plug it in at home, you're all right.
Okay. Thank you.
We wanna do it right now, but we can find tires in the lab.
Oh yeah. Well, if you want, you could just. If you want, you could just. So all the stuff's in those, and so if you guys have time, you could just wire or wheel this over to the lab.
Yeah.
I'm gonna steal it back at 2 o'clock.
That's fine. Where in the lab does it go? By the desk? The professor's desk or?
Just somewhere where it's not gonna be in the way.
Okay.
Wait, here, actually, let me give you a couple other things. This is a good, yeah, here's a good clipper that I was using.
For the assignment, do we need to take a picture of the cable or how do we like turn it in?
You'll check with the TA or myself at some point. I said it's due at the last day of the semester, that way there's not like a traffic jam. Check it out.
If we do it right now, can we just take a picture and then show you the picture on our phone?
Yeah,
What do you mean, your office?
Yeah, you could take, well, the thing is, I wanna see, but it says in the
Dude, are you
instructions.
like the super
that
behavior
requires
class
it to be,
also? What?
It's shoved up nicely inside.
Oh my god. We should be friends.
No, I have a mess to go to right now.
Yeah, why? Why are you so far away?
I suppose.
Is that, what seat do you
I had thought
prefer in a
about it,
classroom?
but you took a
Is this
picture.
of that?
It doesn't
Where you
matter.
usually
How's
sit?
this?
I usually sit, I
Yeah.
usually sit like on the left side of the classroom.
Plugged into
I've noticed,
there.
like here
Okay.
or there.
Okay, good.
We'll do that.
What do
We'll
I
handle
notice?
it.
Now you got me thinking about it.
Yeah.
It feels like I always sit on the right side of the class.
I feel like people gravitate. How you go?
The back.
The back, like back center?
Well,
Just you see everything?
usually a side actually, not the middle.
Got it. Hey Lars, we're talking about where do you tend to gravitate in a classroom, like where do you sit?